He didn't just say that.
Well, it was implied.
It was implied.
How do you imply?
When you sit next to someone,
Okay,
you're
you remember
implying
you don't say
hello
hey.
to you.
Okay.
No, not necessarily.
You remember?
Shut up.
When somebody else implies, you have to infer if you're gonna get what they're wanting, okay?
You were sitting in a cell with a big black gay guy, or are you implying that he's saying hello?
No.
No, Brian to be in the corner in a ball, crying.
Yeah.
Yeah, and you realize
All
exactly.
right. Okay, guys, let's talk about this for a minute right here. What we're looking at here is the load level and suspension system, like my dad's car has on it, and like the black car that belongs to the college has on it. And we talked the other day about how whenever you go to put your vehicle on the lift, you got to turn off the suspension so that it won't see ride height that's too high. Now, Daniel, last semester, actually replaced the air suspension pump on a Mercedes SUV that Denise drives, and because it was throwing a code saying that it couldn't pump up fast enough and all that. Behind you two guys up there, Zane, there's two compressors. I want you to bring me them two compressors. That compressor and the one next to it. Air suspension compressors. We'll talk a little bit about those. There's one, and there's another one up there too. Now, they were told at the Mercedes dealership that air suspension compressor, bring those to me. That air suspension compressor that's in your right hand, if they put it on, it's going to be, I think, $800 or $1,000 or something like that. And so what we basically did was when we determined that we needed a compressor, we went on Amazon and got one. And it was, just exactly like this. And it's basic, and so Daniel put it in there. She hadn't had any more trouble with air suspension. But what this basically is, if you take it apart, it's got a motor, and it's got a little crankshaft in here, and a little piston that goes up and down. And notice it's got these cooling fins and all that. This one here is the one off the Mercedes. This one here is one that we changed out on Lincoln. Now this one right here is just for rear air suspension. This is a dryer right here. And these two lines right here, if you ever have to take one of these lines off, these little plastic lines just stick in there. What you're supposed to do is mash this little orange thing and unhook the lines from it. Now back there on these springs in the rear, well, we'll talk about that as we go through this. You're basically, if you put stuff in the trunk, jacks it back up to where it's level again, you're going to have, basically you're wanting to keep it level. But some of the nicer cars have got four-wheel air suspension on them. And that's what this particular thing's about right here. Now here, you see the representation of the front air springs and the rear air springs. They've got air springs all the way around, and it's basically got ride height sensors at every corner. See that sensor right there? There's another sensor right there. Typically, both of them will be using the same sensor in the back, although some of them can have two sensors in the rear. Now on some of the Lincolns, what we used to do is we take our scan tool, we plug it in there, we would measure from the bottom of the wheel to the fender well, and we would report those numbers to the scan tool, and then it would use the numbers that we reported to fix what was wrong with the leveling of the car. That way you're basically burning in a new set of parameters and all that. And so what we got here, you notice right there it's telling you that. So you got all these air suspension systems are pretty much computer controlled if they come from the factory like that. Now General Motors uses a different kind. They've got something on the back of theirs that look like air shocks. And they got a funky little sensor, and basically all it does is really a simple system, and all it does is it's reading the height of the thing and it's putting air in there. And those you don't have to turn off the air suspension when you raise them up. Not as big of a deal on those. That'll be like on your Pontiac Montana and those kind of like that. All right, so your ride control systems are going to have a little microprocessor back here. You don't usually see a lot of Tauruses with them, but they're showing a Taurus right there. And there's basically going to be some troubleshooting diagnostics that you're going to go through to it. Now you got three different, how many different kinds of codes? You got P codes, B codes, C codes, and U codes. Whenever you're using your scan tool. So a P code is what?
Powertrain.
Powertrain. C code is what? Chassis, that's right. What's a B code?
Body.
Body, and then what else? Is a U code?
Everything else.
Network. U code's network, you know that, right? All right, so look at this. You guys have been fooling with struts. You see that right there? Basically, there's going to be some modifications here that are necessary whenever they've got this. All right. They got conventional suspension system with adjustable damping rate shock absorbers or struts. Now, how would you change if you had shocks and you wanted them sometimes to be firm and sometimes to be soft, how would you do that? You got any idea? You're the engineer now, you gotta come up with something. I want shocks that whenever my little microprocessor determines that I want firm ride, like if I'm going fast, or I'm hitting the brakes really hard, or if I'm cornering really fast, I want firm suspension. Firm suspension is gonna make it less likely to roll over, right? So I'm gonna make my suspension go from soft, like riding on a cloud, to firm, like when I'm cornering and I'm having to do something to avoid a deer or whatever.
That probably got like something like the airbag switch, got the little BB that rolls around in there. I'm talking about,
BBs, you mean like the thing you were talking about with the mercury switch?
yeah, like it.
Well, I mean, I mean, the sensor part of it is what you're talking about there, but what I'm talking about is the part that, how mechanically would you do that?
Well, you could put like air shocks on it and pump air into them.
That's gotta happen instantaneously though, that air's not gonna go in there that fast. You know how shock absorbers work to begin with, right? Anybody knows how shock absorbers work? Remember, you got jelly stuff, it's like glycerin that's really thick, all right? And you got a rod with a plate around it that's got a seal on the outside, and it's got little bitty holes so that whenever that shock goes up and down, that glycerin's got to go through those holes back and forth. Of course, you got nitrogen charged shocks too that they change the mix, but this is the basic stuff. Okay, what if you put two plates so that all the holes were lined up, but you could turn one of those plates so that you stop up half the holes? Got it? Not complicated, is it? On the very top of the shock on some of the vehicles that I've worked on, and they've got other ways. General Motors has got this weird stuff that's sort of like jelly, but whenever you juice it up, it turns solid. You know, it's a strange kind of a deal. But one way or another, the ones that I used to work on had little actuators on the top. There were 4 wires going to that actuator. 2 of the wires would be reversing the polarity, the other 2 would be a sensor. So it would know if it was firm or soft. You could flip a switch on your dash if you were driving a Super Coupe or something, and you could tell it I want firm suspension or I want soft suspension if you got tired of it bouncing. Here's another thing. Sometimes when you replace the shocks on a car with some of the super duper variety you get at the parts store, this one guy came in and had a Lincoln Mark 7 or something, and he said, I had all my shocks replaced with the ones I got from the parts house, and it rides a lot harsher than it used to. Well, the shocks he got from the parts house were not the OEM shocks, and they were firmer, and he didn't like the ride. The only way you can fix that on those would be to replace the shocks. This is what this is talking about. Actuators are controlled by a standalone or integrated control module. Uses various input signals to determine the need to switch the shocks. At the base of the steering wheel, you got that little thing with a bunch of holes in it that's going between optical sensors. And when you turn the wheel, if you see that happening, the variable steering we were talking about a couple of weeks ago, it uses that same input and all that. Okay, so that's a notes page. We're gonna keep going. There's review questions. All right. There's your air pump system hardware. Notice it's got this motor down in here. You notice that's a little crankshaft and a piston. There's also built onto this same thing, you might even notice this right here. This right here is going to the pump. You see them big heavy wires? Well, these 2 wires right here are going up in here. That is a solenoid that releases the pressure. Now some of these, believe it or not, you'll actually look under the hood. This one here on the Lincoln's mounted way up under the air cleaner where you can't get to it. Some of them on the Continentals were mounted where you could see them, and they'd have an air chuck on them if you needed to air up your suspension with an air chuck.
How much does them things cost?
$350 for that one. This one here, if you buy it on Amazon, it's about $350. If you buy it from Mercedes, it's about $850. You know, it depends on where you go, but I mean, it's the same one either way. But long and short of it is you got desiccant beads in that dryer, which is this part right here. What you're basically looking at is this thing right here. See that? Now you see this right here shows you the one with the air chuck on top of it. This one here doesn't have that. They got a place for it, but it doesn't have an air chuck on it. All right, you got the compressor O-ring seal vent solenoid. You cannot change the dryer by itself, if I remember right. You got to, or that's the way it was when I was doing this. You got to do that. And it's a compressor. Solenoid vent valve is really important, and because it's basically how it lets it out. You've also got 2 solenoids, and I think I got one in here. You got 2 solenoids on the rear, on the one that's got, well, actually 4 of them if it's four-wheel air suspension. This thing right here is an air spring solenoid, and it basically looks like a fuel injector. And it's in the top of that. Now, let's say you got one that's leaking down, like my dad's was. When you turn it on in the morning, he'd park his, and when he came back the next night, the next morning it would be, at night he'd park it, next morning it would be squatting down. He'd crank it up, and by the time he got down to the red light, it was jacked up level again. But of course it rode rough until it was. So the way you're gonna figure out what's wrong with that is you can basically take the air springs off, because they're not hard to take off. You just got a little clip on the top, you gotta disconnect this, and you can air those springs up kind of gently with regulated air. You don't want to put full shop air in there, and hold them under water and watch them bubble. If that happens, you got bad springs. Now what we did on my dad's car and what we did on Alice Powell's Lincoln is we got rid of the air springs and put regular springs and shocks in it. And sometimes that's the best way, because sometimes the air springs will cost $100 a piece, and the kit that comes with new shocks and springs is about $185 or something. A lot of times it's cheaper just to go ahead and get rid of that stuff. Sometimes you may be looking at an air suspension light. My dad said, "I'm always seeing my air suspension light," and I said, "Really?" And he goes, "Yeah, I've got that switch turned off in the trunk." And I said, "Well, that's why you're seeing an air suspension light, because he turned off the switch. I mean, if you got the switch turned off, it's going to stay on all the time." When this stuff first came out back in the 80s, and I was working at the Lincoln dealership, the way that you would put it in a diagnostic mode was you had to ground something. You had to open and close the door a couple of times, and then it would start flashing out codes, which was crazy as all get out. Solenoid vent valve is in the air compressor cylinder head. It's right here, and it has a common electrical wire and harness connector with a compressor. That's what they're talking about here. So you have the same wires plugged into it right there. It opens when the control module determines the vehicle needs to be lowered. When the solenoid vent valve is open, in conjunction with other air solenoids, it provides an escape route from air. Now, did you read that little book and see the little test I gave you? Who did? On the air suspension. One of the questions on that test that I asked you is, why would the position of the door have anything to do with the air suspension? When you open the door,
Puts weight down there on the other side.
well, it does, but what's more important than that? Because you'll have to read this what I'm getting ready to tell you the answer to is not in that booklet, but I want you to be thinking about it. What is it? Why is it, if I'm designing this thing, why would I be concerned about whether or not the door was open on an air suspension system?
Well, you don't,
Somebody's getting in a ride.
Yeah.
Weight difference.
Well, that's not it either. What if I open the door, right, and then somebody gets out, which is a way different, but if I open the door and it stays open for a little bit, and the big guy got out and the car comes up and it says, this is really too high. The ride height sensor is reading too high. So it says, I'm going to let the air out and level this thing up. And then the door comes down and either bites into the dirt of a grassy knoll or it gets on the curb. So what happens if you've got the doors open, the air suspension is not going to correct in that direction. You got me? So keep it in mind that if a door switch is lying about whether the door is open or closed, you may have an inoperative air suspension for that reason. You got to think that way. Do the door switches tell the truth? And let's say that you're looking for an air suspension problem that's beating you up, but you're ignoring the fact that the door jar light's on all the time. You got me? See where I'm headed with that? Okay. All right. Now, you got your air spring shocks and struts. They look a variety of different ways, and that's what they look like there. There's not really a whole lot to this system. It's a pneumatic spring, like a balloon filled with air, but it's really thick rubber. I mean, it's almost as thick as a tire, and almost as tough, but it's not really made to touch the pavement, but it's pretty good. You don't typically not going to pop them. This thing is not going to put up enough air pressure to bust one of those springs. I mean, it pumps the pressure, but it doesn't move the air very fast. So if you got any idea you're going to put an air compressor on there to air up tires on your truck, find something else to do, because this ain't going to do the job, right? Now, air lines are used to distribute air from the compressor to solenoids, and the shocks, the lines connect the components with quick connect fitting. How many of you have ever put air shocks on a vehicle? Air shocks have got little lines, and they got little air things in the bumper. You know what I'm talking about. Now, sometimes you'll have a fancy little air ride compressor you can put on there that will actually keep your car low. That would raise your car up. You know what I mean? You can put air shocks on there all the way around.
Yeah, I wonder how much that would cost.
Yeah, probably pretty much.
you can just bag it.
Yeah. See this right here? This little thing right here, see that? That look pretty good over there? Except I got it like that. See, it even looks like what's on the screen, doesn't it? Right there. Right there. That's what that is. All right. So damping shocks and struts are the ones that basically are telling, see this little thing at the top, that number 1 item? That's what I was talking about. And I built a little box that had a little power window switch in it. And I got a connector that would plug right into that. When I had a problem with one of these throwing a code or not working right or had a light on, I would go to the one that I was thinking was giving me trouble, and I would plug that little box in and hook it up to the battery, and I could operate that thing independently of the vehicle back and forth. Had a little indicator light that I put on my box so I could tell if the little sender, you know, the little indicator telling it whether it was in one position or the other would light up on that. The long and short of it was, sometimes I would have to take that off and grab that little stem that was going into the bottom of that actuator and turn it with pliers to see if it was locked up. If it was, you'd have to have a whole shop. The worst part about it is, some of these dadgum things are only this far from the package tray, and you can't get hardly anything on them to turn those, you know, we've got to take the shock off to, you know, get to it and all that kind of stuff. But there's a mechanical valve. It says, enclosed in each shock or strut will be some kind of mechanical valve assembly that enables switching between soft and hard. That's what I was describing a while ago. All right, you got a rotary actuator assembly, damping valve, shock strut assembly. And that rotary actuator assembly that's on top of the shock's only got 2 positions, basically. On some of them, the service switch provides power. You will see this on Expeditions sometimes. Sometimes you'll see it on Explorers, and the air suspension compressor pump on some of the SUVs will be back there in the back.
Navigator.
Yeah, Navigator, that's right, you had that on the Navigator you worked on. And so you've got to switch this thing off, and typically you got to find out where the switch is. On the cars that'll be in the trunk, when you're sitting in the driver's passenger seat, it may be above your right foot where you switch it off. And so if you don't switch it off, you got issues. I forgot about that Navigator you worked on, we had that. All right, and some of them are shipped with it in the position, you don't know that. When the ignition is switched to run, the module is active, and that allows the module to make adjustments to the suspension as needed, but when it's off, the suspension module will only stay active for 30 to 60 minutes because they don't want it running the battery down. That's the reason for that. You'll read about that in your little book I gave you too. Before we get out of here, we're going to hit you with this. If you guys haven't taken that little 3-question test, and Brian did on that one had turned in before the end of the day, where I may just pop test you on it. Front and rear ride height sensors. That's on your Navigator. See those ride height sensors? That's what they look like. Now, they're not typically a potentiometer. Typically, they're going to be set up so that whenever it's where they want to be, a little contact will be made. Also, something else you might want to remember, these are hardwired to ground, and the module puts power out to them. They don't work like an injector does, unless you're talking about a 87 to 90 Jeep Cherokee. All right, so the number of height sensors on the vehicle depends on the type of electronics. The digital height sensors right here, you got some analog ones, but the ones that I always found myself working on were these right here. It's this on-off signal, 2 separate signals, but both of them are on. I built a little box that I had little lights on it, and I would hook it up to all those sensors, and I would actually want to see it, you know, see whether it was in range or not myself. And if I would, when you put the thing in self-test, it will raise and lower all the springs, and it will look for the ride height sensor to respond to that. The ride height sensor is the feedback. The suspension control module uses a door signal, such as preventing venting or maintaining current ride height when the door is open. See what I'm talking about? And the system returns to normal when the door is closed. All right, this is how you get this stuff. We've seen these kind of things before. It's either getting it from directly to the control module to the other one. There was a Lincoln commercial that I don't remember if you guys ever saw. And they showed this Lincoln, it was a Mark 8, I think, or something. And it would drive down this test track, and there was a concrete barrier that was up off the ground a certain amount. And this guy would drive down here, and he would drive that car right up there, and it would touch the barrier. The top of the car would touch the barrier, you know, right at the, close to the roof. And then he would back up, and he would go down to the other end of the track, and he would come back at 75 miles an hour toward that barrier, and we'd go under it. Because whenever you got to get to road speed, it would lower the car a certain amount of time, usually about an inch. But they were doing that to make it dramatic, so you could say that, you know, oh no, he's gonna rip the top off of that car, but he went under it. So anyway, you know about that.
I bet it's still 10 stuff.
There's the steering wheel rotation sensor I've been describing. You'll see that. They'll have this little wheel on them even if they don't have a steering wheel rotation sensor on them. But if it's got steering wheel rotation sensor, it's going to be talking to your your air ride, your strut damping or something like that. You got an acceleration signal provided by the PCM to the suspension to activate the suspension to hard damping to reduce front end lift. Now there's two different parts of this. There's the leveling and there's the damping part of it. So you're not talking about the same thing, but both the same box does control them both. All right, so you got brake signals. You stand on the brake, that's the brake signal I was talking about that bled the fluid through there and got the transmission messed up the other day. And it's also a cancel cruise control. But anyway, if you mash that thing hard, good hard brakes, it'll go to damping, and that's the inputs of it. And we're not going to go a whole lot deeper into that. Some air suspension systems use a transmission input for height adjustment needle strategies. The needle strategy is when it squats down when it's driving down the road at highway speed. And that's spliced into the, what's a DTR circuit? Anybody know? Has anybody got any of these worksheets on a digital transmission range sensor? And I want you to look into that. Pretty important that you understand that. All right, and then you got a ride control personality select switch. And I'm not going to go through this whole thing, but I just want to give you guys sort of an overview of it. The transfer case settings. See, some of them, 4x4 vehicles, that seems like too much candy for a nickel, don't it? 4-wheel drive vehicles with ride control suspension, you're going to use a 4x4 mode switch as an input. You got an off-road mode switch, allows it to activate the air suspension to raise it up to get more ground clearance. Seems like a pretty good idea. And then your shock absorber actuation feedback, it works like that. See how you do that? You got a control manual actuator circuit, you got a feedback circuit on there. So that one just shows 3 wires. The ones that I saw had 4 wires, but they actually use the ground that's hardwired to both the switch and the motor. All right, that's where I'm going to stop today, but I'm going to ask you these questions before we go. We got a minute or two. And Brian filled out that one. Okay, on the, let's look at the 3 questions that I put you guys up on the, for that brake test yesterday. The average human the average human can hear between what and what hertz?
20 hertz and 20,000.
20 hertz and 20,000. And can tolerate up to how many decibels?
130.
130 decibels is how much? I mean, what's 130 decibels? Somebody give me a.
Extremely loud.
That's pretty doggone loud. It's louder than a skill saw, right? What are the 3 available options that can be used to deal with the kind of noise referred to in the handout? Brian, you remember? Because you answered this. 3 available options to get rid of brake noise would be to do what? Why don't we shift or change the frequency of the noise? Because that's one of the things, isn't it? Suppress or eliminate the path of vibration of transfer. And then you can dissipate the noise by insulation or absorption treatment. How many of you guys have ever seen this thing sticking off of an exhaust or sticking off of something and you're saying, all this is a piece of rubber that's hanging up here, or it looks like somebody put a weight on it. It's just got a little arm sticking off, like on the Crown Victorias, you can look under there. You got these things that look like cans sticking off the exhaust. Those basically change the properties of the exhaust so that it will not make vibrational. If you take those off, it's going to feel different driving down the road. You may have, what they call a body boom or something like that. Okay, and finally, the most brake noise comes from what?
Friction.
Friction coupling. Good answer, Amber. Those are the 3 questions in that book over. That little book is not very long. You can read that book in 6 minutes. It's not very long at all, the little booklet. Tomorrow, I'm going to be giving you out a booklet on continuous variable transmissions that you need to read, and I may put together a test on that one that's a whole lot harder. Also, today's handout came with a test that's got 5 questions on it, so you make sure that you read that and go through those questions, okay? Everybody got your little book? What you got there? Which book you got there?
Air ride.
You got your air ride book, okay. All right, so everybody soak that up because I want you to be knowledgeable about it.